Hello grade 10s, welcome to the last week of models and plans, and this week we'll be focusing on packaging. Now the packaging of goods in order to minimize cost and breakages of fragile goods is important. So this whole week's lessons are going to focus on this aspect. So let's start with looking at some tin cans. Now tin cans come in all sorts of shapes and sizes, and here we've got a picture of 3 different cans and the dimensions of the cans. Let's have a look at questions that can be asked around these. Now our smallest tin, so that's this one over here, is shipped in cartons of 24 cans per carton. Let's have a look what it looks like when they are packed. Okay, so here we've got the box and it shows the cans being packed in the box. Now how many layers are there going to be? Okay, so we need to have a look over here, and we can see we've got 4 cans going lengthways and 3 going this way, which means we're going to have 12 per layer. Okay, so there's going to be 12 per layer. And we said that there are 24 of these in the box. So if we've got 24, and we're going to divide that by 12, and we're going to come up with 2 layers. Okay, let's have a look again at our diagram here. Okay, so the picture shows exactly how the cans are packed. How many cans are there in the length and the breadth? Okay, so we can see that in the length here we've got 4, and in the breadth here we have got 3 cans. So what we want to do now is we want to determine the minimum size of this carton in order to hold those cans. So the first thing we need to do is we need to see exactly what size those cans were. Okay, so let's have a look. We can see that our cans are 84 millimeters each. Okay, so our length is going to be 84 millimeters multiplied by the 4 cans that go in the width. Okay, so if we do that on our calculator, we're going to have 84 multiplied by 4. That gives us 336 millimeters. Now in the breadth of our box we had 3 cans, so we've got to go 84 multiplied by 3. Okay, so 84 times 3, 84 multiplied by 3, that's not such a difficult one, 252. Okay, so this again is millimeters. Now our height of our carton, we know that we have got 2 cans, and the cans are 34 millimeters each. In other words, it's going to be 68 millimeters. So in other words, the minimum size that our carton can be is going to be 336 millimeters by 252 by 68 millimeters. Okay, so here we've got our medium-sized can. Now this can also comes packed in cartons holding 24 cans. What we want to do now is we want to calculate the minimum amount of cardboard, and we want that in square centimeters in order to make 1 carton. Okay, what we're going to do is we are going to round the dimensions, and we're going to round them up to the nearest 5 millimeters before calculating the actual surface area of the cardboard that we need. Okay, now we get given the formula for that. Okay, so our surface area formula is twice length breadth plus twice length height plus twice breadth height. Yeah, so we're going to use this and substitute all our values in. Okay, so now we've got this can, and it's also being packed into a box of 24, which means with this one we're also going to have 4 cans in the length and 3 in the width and 2 in the height. So the first thing we must do is calculate those measurements. Okay, so our length is going to be 4 multiplied by, let's have a look at our width over here. It's 72,9 millimeters. Okay, so 4 times 72,9. Let's do that on the calculator. So it's 4 times 72.9. And remember, we said we want to round it up to the nearest 5 millimeters. We're going to go up to 295. So this is going to be 295 millimeters. Okay, so strictly speaking, this over here should be an approximately equal sign. But these are what we're going to use in our calculation. Okay, so our breadth is 3 times, also 72,9. It's going to be 3 times 72,9, and we're going to round this one off as well. Okay, so 3 times 72.9, and that gives us 218,7, so we're going to make it 220. Okay, so this is going to be 220 millimeters. And then our height is going to be the height of 2 cans, also 12 per layer. So it's going to be 2 times 113, and 2 times 113 is 226. So when we round this off, it's going to be approximately 230 millimeters. Remember, we said we must round up. We can't round down because then we're not going to have enough. Okay, so now let's calculate our surface area. Okay, so our surface area is going to be 2 times 295 times 220 plus 2 times 295 times 230 plus 2 times 220 times 230. When you're using the surface area formula, please be careful and make certain that you've got your dimensions right. You can see over here I've got two of each of the dimensions. So they're the 295s, they're the 220s, and there's the 230s. Okay, so now we need to multiply all of this up on the calculator. Okay, so it's going to be 2 times 295 times 220 plus 2 times 295 multiplied by our 230, and then finally 2 times 220 times 230. Okay, that gives us 366,700. Okay, so it's 336,700. These were millimeters, so our answer is going to be millimeters squared. Okay, let's have a look at your homework question. Your homework question is going to revolve around the large can, which I've got a picture of over here. Now, the large cans are packed in 2 layers and there are only 12 per carton. I want you to calculate the minimum size of the carton that we're going to need, and you must round your answers up to the nearest 5 millimeters.